Ever have one of those days where you're building a practical tool 1 minute and then wrestling with a super complex algorithm the next? That was today. We're creating a brand new browser extension and tackling 3 LeetCode problems, including a hard one that really stretched the brain cells. This is day 60 of coding every day until I hit 1K subs. I started the day off with some project work before diving into the LeetCode grind. Let's get into it. I started a new project today, a browser extension designed to improve the user experience on Google's AI Studio. It's a simple idea, but one I think will be pretty useful for my own workflow. I started by setting up the project and writing the initial documentation to lay out the vision. The core idea is to add a few quality of life improvements. The main features are moving the copy button to a more intuitive spot and making sure that when you copy a response it keeps all the markdown formatting like code blocks and lists. It also sets a simple static placeholder for the main text input, which I personally find way less distracting than the default one. Under the hood, it's a pretty standard content script that watches for changes on the page. When it detects a new response from the AI, it injects my custom copy button right where it needs to go. It also finds the main input field and just overrides its default placeholder with the static text. Simple, but effective. I also spent a bit of time working on the automation for this YouTube series. I made some improvements to the Python scripts that help me prepare these code puzzles, focusing on making the whole process more reliable and streamlined. It's the behind-the-scenes work that makes producing these videos every day possible. Alright, time for LeetCode. First up is problem 2200. Find all k-distant indices in an array. Spoiler alert. The goal here is to find all indices I in an array, such that there's at least one key value at an index j, where the absolute difference between I and j is less than or equal to k-fev. This solution uses a straightforward, brute force approach. It involves nested loops to compare every index I with every other index j. A set is used to efficiently store the valid k-distant indices, automatically handling duplicates. The final result is a sorted list derived from this set. This runs in order n squared time due to the nested loops, and uses order n space for the set in the worst case, where n is the number of elements in the array. Next, a medium problem, 2311. Longest binary subsequence less than or equal to k. Again, spoiler alert. We're given a binary string and an integer k for its. We need to find the length of the longest subsequence of that string that forms a binary number less than or equal to k for its. This problem is solved with a greedy approach. The code iterates through the binary string from right to left, processing the least significant bits first. Zeros are always included as they contribute to length without increasing the value. Ones are only included if adding their positional value, which is 2 to the power of push the total sum over the threshold k. This achieves a time complexity of order n, where n is the string length, with constant space. And now for the hard one. Problem 2040. Coughed smallest product of 2 sorted arrays. Last spoiler warning. Given 2 sorted arrays, we need to find the k-th smallest product you can form by taking one number from each array. This one is tricky because of the negative numbers and the sheer number of possible products. This hard problem is tackled using a powerful technique: binary search on the answer. Instead of generating all products, we search for the result within the possible range of product values. For any given value we test, a helper function determines how many products are less than or equal to it. This counting function itself cleverly uses binary search to quickly find the number of valid pairs for each element, handling positive, negative, and 0 cases separately. This lets us efficiently narrow down to the correct k-th smallest product. And that's a wrap for day 60. If you enjoyed the mix of projects and problem solving, a like and subscribe would be amazing. Let me know in the comments if you've ever built a browser extension or have a favorite approach for these kinds of LeetCode problems. You can also support the channel over at buymeaboba.com, link in the description. See you tomorrow.